pH of salts in salt hydrolysis. We saw that a neutralization reaction between an acid and a base gives a salt. This reaction is between a strong acid and a strong base and produces a salt, NaCl, that is neutral, that is, neither acidic nor basic. The cation from the strong base Na+, and the anion from the strong acid Cl-, will not react with water but will remain as aqueous ions. If, however, the neutralization reaction is between a weak acid and a strong base, the salt solution that is formed will not be neutral. Let us see why. In this case, the cation from the strong base will remain as aqueous ions in solution. It will not react with the water molecules. However, the anion from the weak acid will have a tendency to react with a water molecule and form HF and OH- ions. This is called hydrolysis. The formation of OH- ions causes the pH to be higher than 7, and it is mildly basic. If the neutralization reaction is between a strong acid and weak base, the salt solution that is formed will not be neutral. In this case, the anion from the strong acid will remain as aqueous ions in solution. It will not react with the water molecules. However, the cation from the weak base will have a tendency to react with a water molecule and form NH3 and H3O+ ions. The formation of OH- ions causes the pH to be lower than 7, and it is mildly acidic. Therefore, a salt that is added to pure distilled water alters the pH of the solution, depending on the relative strength of the acid and the base from which the salt was formed. Let us take some more examples. NH4Cl has its cation from a weak base, NH3, and its anion from a strong acid, HCl. Therefore, it will be acidic when it is added to H2O. KNO3 has its cation from a strong base, KOH, and its anion from a strong acid, HNO3. Therefore, it will be neutral when it is added to H2O.
Starting to feel it? Now go master it with